So whatever, but my name is Evan, and we're going to be talking about doing OLAP with Spark and Cassandra, two things that are near and dear to my heart. So a quick intro, I'm actually not, I work for a company called Socrata, which is based in the Seattle area. I'm actually not from Seattle. I'm up here for the summer, and I'm enjoying it very much right now. When I first got here, though, it rained for 4 days straight, which seems like very typical of the area. So anyway, I've been working with Apache Spark and Cassandra for a while, and I created something called the Spark job server. Later, when the slides are sent out, you'll be able to access all the things. So tell you a little bit about Socrata. We're based close to Pioneer Square, but we build software to make data useful to people, more people, and specifically public data for citizens. So there's a lot of websites that we've done that opens up data sets from government, and our goal is really to help citizens learn more about government, to help governments be more accountable. You can see how governments are spending their money. We believe strongly in helping improve government. So, reason why I'm giving a talk, so everyone has a huge amount of data. How do we query it and analyze it efficiently, right? In my last job at Riala, we were getting about 3 billion events a day. Even if you were to take that and create a roll-up table with it, that works out to about 30 million rows a day. And people want to run queries on a year or maybe more worth of data, right? So how do you do that? And at Socrata, we have tons of data sets, each of which are in millions of rows. So again, in the aggregate, you end up with a problem where this could easily scale into billions. And in addition, individual customers are quickly asking for data that is 1 to 2 orders of magnitude bigger than it is today, right? So the big question in everyone's minds: how do we allow people to query a lot of data quickly? You've heard John gave an excellent talk earlier about the basic Cassandra that you want to do normalize, but sometimes you can only do normalize so much. If you want people to be able to run, if you want to be able to support more complex types of queries, joins, different things like that, it is really hard to materialize, or maybe a lot of times impossible to materialize all the different answers that someone could want. You just end up with way too many combinations. And you need a way to do more flexible, to be able to answer questions in a more flexible way, right? But at the same time, you also want to do it fast. So if you look at the ways that people have traditionally done this, traditionally people have used an RDBMS or this sort of thing. So you write data in, you run SQL queries out. Do we have a question? Okay. You find that you start hitting limits at various points. I think for us, when you get to about 10 million rows, you start. It depends on exactly what hardware you use, but you start hitting limits in terms of SLAs, and it depends on the type of query as well. For you're trying to do more complex group bys, and you hit that limit more quickly, right? The other thing with RDBMS is that I'm probably preaching to the choir here, but there isn't really any good solution for, at least an inexpensive solution for sharding and querying. Well, you can buy Oracle, but no one wants, who wants to do that, right? Hopefully no one here works for Oracle, right? There isn't any robust way to scale it horizontally. There are some new things that are coming out, like Postgres as a XC, XL cluster kind of thing. We've tested it, found that it is in really early stages. So at this point in time, there's no magic distributed RDBMS, right? And typically what people resort to is pretty complex and expensive ways to improve the performance. you can work on roll tables, you can work on tuning it, but each thing that you do tends to involve a lot of man hours, right? And it only gets you so far. The other way that people traditionally solve this problem of slicing dicing data is using OLAP cubes. OLAP cubes started in the 1990s, huge ton of research papers for doing these kind of things, which it works well because what OLAP cubes do is that they materialize every single possible answer and combinations of answers that you would expect in a way that you can get out quickly. So this is a time-proven approach. Only problem is that, like, as the size of the data grows, the size of a cube grows exponentially, or with regard to how many dimensions are in the data, and quickly at the levels of the size of the data we're talking about, they start to get untenable, and nobody really knows how they work. They're usually it's very proprietary technology. A lot of papers have been written about it, but like, it's one thing to have a paper, it's another to actually understand how it works and to debug it in production. So, and there are very few solutions for cubes that scale horizontally. Actually, there probably are, but again, they're very expensive. So what do we do, right? You guys all know who Ken Thompson is, and he said, "When in doubt, use brute force." Now, as software developers, we probably are trained to think this is a very bad idea, right? Brute force, like, you go to programming interviews, you're always taught, use the best algorithm. But there's actually a really good grain of truth to this. That sometimes the best way to solve a problem is to keep things simple. Actually, a lot of times, and to work on efficiency, right? So I introduced you to two technologies that Cassandra as well as Spark. That Cassandra you're probably all familiar with, but we'll talk about both and how we can use them together to help solve this problem. So as you all know, Cassandra, a wonderful technology, horizontally scalable, can model your data in many different ways. And it's relatively easy to operate. By relatively, what I mean is that every node is like the same type of node. You don't have to worry about, well, do I have a worker node and then I have some kind of master for serving files and this kind of and that kind of thing, right? The only thing is that Cassandra works when your queries are simple, right? So you can, like, you have an exact, you're looking for point queries, or you're only looking for data from a few rows or like a simple range query. If you're trying to do things like joins or commutations, then typically you have to do those client side. Sorry.
You start with that relational database is becoming a problem, then you group by across layers of code. Then you discard relational database from a possible solution. Now come back to Cassandra as a possible solution, but you say that you want to group by to have a form query. So what are we looking at here?
Right. That's what we're going to talk about. Yeah. So just hang on. So. I would like to introduce you to Apache Spark. Many of you guys probably have heard of or are playing with it, but I'll just run through this for everyone who's not familiar with Spark. Spark is essentially like an in-memory Hadoop. It's horizontally scalable. It can cache. So Hadoop has HDFS. Spark can work with HDFS, but Spark can also cache data in memory. It's designed around a functional API for working with data, so that you can take your data as an immutable collection and transform it in different ways. You can group, by, filter, and do most of the basics that you would need for data transformation in a very easy way to use. The really neat thing about Spark is how much momentum it has scattered. I was just at the Spark Summit in July. This is the second summit. It has like over 1,000 people. The first one was last December like less than 500 people, and it's just amazing. Like every single vendor of Hadoop has added Spark as an add-on, and it has just an unbelievable like. It has 10 times more activity than any other big data project, pretty much. Developers really love it. There is now. It's called Databricks. Databricks. Yeah, they received $14 million in the first round. Anyway, you want details, you can look it up. What's really neat about Spark is that so traditionally in Hadoop, you had Hadoop itself, which is MapReduce. Then you had a separate project, which is graph computation. You had Hive, which is again a separate project. And typically moving data between these projects is not that easy. With Spark, you have a lot of components that are built on top of Spark. You have an SQL component, you have a machine learning component, a graph component, a streaming component, and these are all tied pretty tightly together.
Sorry, could you repeat that?
Oh, I'm sorry. Yeah, sure. So Spark has a lot of components that are tied very tightly together. There is a streaming component, an SQL component, a graph component, and a machine learning component. So an example of something that you can do very easily with Spark is that I can take data, load it in memory, run an SQL query on it, take that, and then run a logistic regression or some other machine learning type of training on that data, which is really powerful, right? In the kind of flexibility that it gives you.
So, as far as in memory, meaning, does it leverages the memory across all of the groups and not go to particular system?
So the question was, in terms of memory, does Spark leverage memory across Hadoop nodes instead of having to go to disk? So Spark is actually, you can think of it as Spark actually doesn't run on top of Hadoop. I can run Spark without installing Hadoop at all. So that's the first thing to clear up.
So you create a Spark cluster.
So you can create a Spark cluster without Hadoop. In fact, that's where Spark and Cassandra becomes very interesting because you can set it up without setting up all of Hadoop, which I think increasingly makes more and more sense. If you don't need to, if you don't already have Hadoop, then it might make sense to skip it entirely.
Is it like for Spark there was a GMS connector, now there is a Cassandra connector?
Right. Now you can still use HDFS.
Yeah, you can
but
still use that.
but you can use Cassandra. Yeah, I'll talk about that a bit more. Right. But yes, Spark will allow you to keep data in memory without going to disk. Although, like if you find that your data does not fit in memory, you might obviously still need to use this.
Does it persist the data at all by default?
You can persist data in different ways. There's different ways to persist it.
But you need to control Spark.
Well, you can specify how data. So there's different. We can get into more details later. But basically, there's different ways that you can cache data. You can cache data in memory to disk, both, or you can export data yourself and write it to Cassandra or HDFS or anyone else. So there's different ways to do it.
I have a quick question, just from a logical model perspective. Cassandra thinks tables and Hive thinks tables.
Yes.
What is the fundamental difference?
Between Cassandra and Hive? Well, Cassandra and Hive are different things, right? Like, Hive is a computation engine. It can read tables from Cassandra, actually, operate. Spark can, again, you can read data from a Cassandra table and operate on it. But Hive and Spark are both computation engines. They're not databases, right? Cassandra actually stores your data and processes it for you. But I'll get to that in a minute. So basically what I'm trying to say is that Spark provides the missing fast, deep analytics that people have always wanted from Cassandra, which is one reason why Databricks, by the way, I don't work with Databricks, but I think what they're doing is brilliant, like partnering with, DataStax is partnering with Databricks to offer this Cassandra and Spark integration. I'm going to talk really quickly about integrating Spark and Cassandra, and then I'll go on to what read in the talk as well. So there's a couple ways you can bring data from Cassandra into Spark very easily. DataStax is this open source the Cassandra driver Spark project, which uses the new DataStax SQL driver underneath, and so you can pull data out and it will appear in Spark and you can use it. There's other projects as well. I'm a Scala person, so I only research Scala ones. I think they're probably farther along than the Java and Python ones, but I'm not sure what the state of those are. But Spark can actually pull from any Hadoop input format. Now, there are actually multiple Hadoop input formats that work with Cassandra. There's a SQL page input format where you can give it a SQL query and it will pull data out for you and in pages, which is pretty nice. And there's older ones that read an entire table, or what we used to call column families. But working with those is going to be a bit, working with formats in general is a lot more painful. You can also, just give you a flavor of what Spark can do, you can also read directly from Cassandra using something like this. So this is the Scala Spark code. I'll go through this. There's really only two lines that matter here. The first line is, you see the sc.parallelize. What that does is Spark can take any list and parallelize it distributed across a cluster. So what we're doing is, first we're saying we have a bunch of row keys. So row keys are, think of them as primary keys, right? So you have a list of primary keys that you want to read out of Cassandra. We're going to parallelize that, distribute that across a Spark cluster. The second line that's interesting is where I'm doing essentially a transformation. I'm mapping a row key to the data contained in those rows by using SDNX, which is a pretty widely used Cassandra library, to do a get on that primary key from the column family, which is a table. And so I start with a bunch of row keys, then I transform it in Spark into the actual data. So that's something that gives you a flavor of the kind of pattern that you typically do with Spark, is that I start with some data and I keep transforming it until I get to the stuff that I want. So even if without those integrations, it's pretty easy to do this directly in Spark. I'm sorry? Oh, SDNX is Netflix library for talking to Cassandra. It's pretty widely used, like a lot of projects. Okay, thanks. Is that better? More? All right. Well, all right. I don't think it blows up anymore. Sorry. Oh, so SC is Spark context. It's basically a basic, like, when you work with Spark, it use it to connect to a Spark cluster. Yeah, it's basic building block. But if you missed this, don't worry. Like, I'm definitely going to post up the slides somewhere so you'll be able to get it. Well, so typically you would have a Spark cluster deploy, and then when you create a Spark context, you give it a string, which is like a URI, and that tells it what to connect to. Oh, yeah, that's a good idea, actually. Could move it back. Oh, maybe.
So this is just setting up
There's no created at this point. All we've done is like read data out of Cassandra and put it in Spark. Yeah, I'll show you an example. Yeah, exactly. This is the extract. This is the ETL. Yeah. So let's talk about the architecture for doing Spark and Cassandra OLAP. Right? It's the exciting stuff. So one of the principles is that we want to separate the storage and query layer. So unlike a traditional database architecture, you think of, I'm going to store data here, I'm going to run a query on it. The idea is I'm going to use the best-of-breed storage platform, which Cassandra is for a lot of use cases. It handles all of the replication, cross data center, failover, this kind of thing for you. And I'm going to use a separate layer for doing transforms and querying, which is Spark, which is right now the best of breed and has the most momentum. And combine both of them while taking advantage of how quickly both of these projects can evolve, right? Because if you look at individual databases, like there's MongoDB, React, and all these databases, the problem is that everyone is trying to do all this query stuff, but they're replicating each other's efforts, right? And they can't move quite as quickly as someone like Spark can. One of the benefits that you get from doing the separation is that your concurrency for querying can have a different level of, you can scale your read concurrency separately from the storage. Let's say that you have data in one table that's very, very like popular, right? And you really want to serve as many people as possible. Well, in Spark, what I can do is I can populate that into memory of multiple Spark nodes, and therefore increase my concurrency. Yeah, so you incur, yes, you're right. So you incur like more I/O costs. So this is definitely a trade-off.
More network.
More network, but I don't know. These days, I'm worried less and less about network. It depends on the data set. Yes. Yes.
So, what essentially you build, right? So if you have your master schema in Cassandra, right? You build some like cache for better column cache.
Yes.
Right?
Yes.
When you do this, did you rebuild your cache like from scratch every time, or did you manage to do incremental population?
Well, yes. I'll preface this by saying that this is really optimized for data that's mostly append only. Like I'm not going to be mutating like some rows a lot, right? I'm get the data once, and I'm probably going to add to it, and there's like very small percentage that changes. So yes, you're right. It does depend on that. What I'm talking about.
So you were talking about kind of here from the Cassandra to Spark.
Yeah, let me show a picture, like in a slide or two, which you understand a bit better.
The previous talk was talking about the other direction, in terms of ETL from the Spark into Cassandra extended, right? So can you comment a little bit about, in what circumstances you want to do which direction? Because which one would be your primary big data storage?
It depends. Well, so Spark is not storage. I look at, so hold on for a second. I'll show you a slide of what.
Yeah, but I'm a little bit confused in terms of common practice because
Oh, I see. Common practice. Sure.
It's like,
you can do both.
And Cassandra was talking about, I want to get data out of Spark into the Cassandra, and you were talking about from the Cassandra.
Here's the thing. After I do some computation in Spark, I'm going to put it back in Cassandra, right? So it depends on your workflow. So I could store, what I'm talking about is storing more like your raw data, or data that you're going to do some interesting query on.
That's the explanation, but the guy, the ex-patent guy, used the term warehouse.
Like he used a Hive warehouse, and the workflow they were working through is extracting from CSV using Spark to transform the data and ultimately loading the aggregated reported data into Cassandra so that it could be RESTful API accessed in that.
Yeah, so I think that's a very different kind of pattern, right? Like that's more ETL. They're taking source data, CSV, and things, by the way. And then doing computation with Spark, and then putting Cassandra where I can do point queries on it. What I'm talking about is a little different. It's more like I've already done the ETL, right? I have the data I'm going to query, but it's really big, and I can't do point queries on it. Now I'm going to load it with Spark so I can run interesting queries on that data. So it's a little bit different part of the workflow, right? The key idea is that you don't want to keep investing in developer time to build to improve the performance of something. I just want to scale the nodes. And so even if Spark is not as sufficient as like Postgres, by the way, Postgres I really love as a technology. It's like open source, and like it's really, really fast at what it does. But in the end, like I want to be able to scale nodes. It's expensive to hire developers. And to keep it simple, when I say keep it simple, what I mean is I'm gonna architect this architecture. I'm going to maximize for what I call row scan speed, which is instead of building a lot of fancy indexes, I'm going to try to go over as many rows as I can as quickly as I can. And I'm going to look for gains in places such as using a column representation to make things fast, and as well as things like bitmap indexes, so I can select out the rows that I need. And that's probably about it. So a lot of people ask about caches. Essentially, the picture is that I've data Cassandra, and I'm going to cache it in Spark. This picture, when I say Spark Executor, that's a worker on a machine. So the data is actually cached in the JVM heap. Now, you could do it this way. You could also do it the other way, where, like, ostensibly, I could have data flowing to Spark, and I could do a write-through cache back to Cassandra. I haven't done that. In theory, it's possible. So that's why I meant, like, it really depends on the workflow. But typically, we write to Cassandra first because it's pretty fast and doesn't incur much latency, and you get the benefit of, like, you know the data is secure. There's a slight variation on this. Spark has a project called Tachyon, which is cached HDFS. And what that does is it accelerates your HDFS reads and writes, but it allows you to plug in different backends. So Tachyon stores data off heap. So the advantage of this is that you're caching data from Cassandra into an off heap source, so that if your process dies, but your node doesn't, you can restart your process and not have to ETL the data again. Right? The support is not there yet, by the way. So hopefully someone will do this. So can you guys see this? Okay, let's try. And if it doesn't work, then. So unfortunately, it seems to be scaling. It seems like that's the most we can do it now. So so you guys can probably, like, I'll just go over this. What the first few lines is basically defining data. This says val rows is equal to a sequence of, and then so this is a nested sequence. Each line represents a row of data, and each value is basically a column. So this was an initial attempt, and basically the important things to note is that each value has a different type. You could have strings, you could have numbers. And then the actual code, the first line says sc.parallelize, so there's that parallelize again. So we're taking the rows and we are distributing it. If this was you reading from Cassandra, you can replace those lines with the two lines that I had earlier, where I parallelized a bunch of row keys, primary keys, and then read it. That's basically the same thing. And so this is what you would do with it. The second line is a map. And so what I want to do in this case is, this is crime data. The first column is the crime type, burglary, theft. And let's say that I want to count the number of crimes by type of burglary, right? So simple group by. So first I would map the values such that I'm getting a tuple with the crime type as the first element. Then the third line is a group by key, which is a distributed grouping. And so now I have all of the values up for burglary, all the values for theft, together in one place. Then the final line is a reduce, which adds up all of the different crimes. So this is pretty basic map reduce. You have basically done in 3 lines. So this works. The problem is that, well, by the way, this you could do today using Spark as code module. When we started, this module was was not ready, so we didn't really use it. But the problem with this approach is that it's very, let me see, look at the time. It's very row-oriented, so I need to pull out values that I need to query. And also, especially for more numeric computations. So in Java, like if you want to store a collection that can store any type, then what you have to do is you have to box your integers, right? And that gets very expensive to pull out an integer, unbox it, add it up, etc.
This Spark SQL going to kill Shark?
They're actually killing Shark. It's getting folded into Spark SQL. So sure. So the question was, is Spark SQL going to kill Shark? Shark is a project. So the answer is yes, basically. So really quick thing about Columnar, like storing things in columns versus rows. You guys know who Michael Stonepicker is? He's the founder of Postgres, like one of the world's foremost database experts. What he has said recently is that traditional row-based data storage is basically dead. This might be partly because he's founded several startups doing columnar databases, but I think he's actually right on.
So, good question about it.
So sorry, I'm going to hold off on the questions because
okay.
I think we're running out of time, and I still have material to go over. So I'm so sorry about that, but I'll be around, so you can ask questions. Traditionally, you store data in rows both in memory and on disk. So let's say you have two rows there. The two columns are going to be stored together, and so the Hillary and 66 will always come after the first row in memory and on disk. When you store stuff in the columnar format, what you're doing is I'm separating out the stuff in each column so that all the names get stored first, and then the stuff from the second column gets stored second. It gets stored together. And you can do the same thing in Cassandra. And I'm sorry, this is in the old Cassandra lingo. This is if you can basically translate CF, which is column family, to table, and row key to primary key, then you'll be all right. So basically, imagine if I stored all of the data. You can think of it as a traditional table, but flipped sideways. So basically, all of the data in one column gets stored in one physical row or a partition in Cassandra. That way, it is stored continuously on disk and can be accessed very, very quickly. Right. And the advantage of going with the columnar format is that you're able to, first of all, you can save I/O because you only need to read in the columns that you need for a query. And that's what all of the work in Hadoop, Parquet, plus Impala, a lot of them have gained a lot of speed just from this single thing alone, is reducing I/O. You also get a huge amount of compression that is much easier to achieve when you store stuff column-wise. Because, for example, like, let's say that I've stored a bunch of names. Well, I know that there are only so many names, and so I'm going to use the dictionary to put a number instead of a string, so I can get a lot of savings just that way, right? And in terms of the JVM, for numbers, you get a big benefit because I can store numbers that are native type without boxing them as objects. So they use up a lot less memory and are more efficient to compute. What the experiment that we did, what we found was that a solution that used the columnar storage approach used 10 times less memory than the initial approach, which was row-based, and was about 1 to 2 orders of magnitude faster for doing improvements. So it's a pretty huge gain, especially for doing numeric computation. So now that we talked about doing OLAP with Cassandra and Spark, now what do we do, right? So get the party started. First of all, I'll mention this again, but DataStax has a Cassandra and Spark integration. So they, there's the previous driver that I referred to for the community Cassandra. There's also DataStax Enterprise, which will be rolling out Spark support. And some of the things that I know they've added is that they have added an HA Spark master that integrates with Cassandra nodes, which sounds pretty nice. The big news on this front is Spark SQL. So this appeared in the latest version of Spark 1.0. It adds an SQL component where you can query the data sets in Spark using SQL. It has an in-memory columnar storage. So it actually stores stuff like I talked about in columns, which minimizes the amount of space you need in memory to store stuff. Although the querying is not, is still row-based, but it is definitely a step in the right direction. And I know that Cassandra integration work is coming, which I've heard from several sources. Right now, there's no indexes yet, so it's basically doing a full table scan every time, although it's still pretty fast. The two exciting things about Spark SQL is that one is that if you need custom functions, you can actually write them in Scala or Java, and then use them in your SQL, which is pretty cool. It's much easier than using Hive ETFs if you use those. And the output will integrate very easily with the machine learning library, with the graph processing, things like this. Hold on for 1 second. Sorry, I can't hear your question. I would say it's best if the functions are written to have no side effects, so it can run multi-threaded. You should always assume that it's going to run multi-threaded. Yeah. I think the work that is still needed from Spark is, for example, right now it has no indexes. So if there's a way to add indexes, you can definitely speed things up for certain kinds of queries. And to be able to read data more efficiently. There's a lot more work, but I think those are the main things. So I'm sorry I'm a bit out of time, but I wanted to summarize that I think this architecture of Cassandra and Spark together can give you very fast, complex querying for certain use cases. That your data doesn't change much. It's mostly an append-only kind of data set. And you're focused on numerical aggregations, then I think that it works pretty well. Spark is at 1.0 already. It is getting less and less rough every day. It's still a young project, but it's advanced far enough and has enough momentum that basically I think anytime you have problems, there's going to be multiple people that can answer them within the same day. Right. Thank you very much.